Alright, so for this drop a question, we have a rational expression that we're multiplying and simplifying. We're having x squared plus 5x plus 6 divided by x squared plus 3x plus 2 multiplied to x squared plus 6x. I wrote that twice. Plus 5 divided by x squared plus 6x plus 8. So when we're multiplying two rational expressions, we want to make sure we factor everything, both numerators and denominators, as much as we can, and then we're going to cancel what they have in common. So if we look at this first one, it's a trinomial, meaning we have three terms. Our highest power is a 2, x squared, and there's no number in the front. In fact, there's no number in front of x squared for any of these. Or if it is, we can assume it's always a 1. Anything multiplied by 1 is just x squared itself, which means that our first terms for our two groups will be x and x. And now I'm looking for two factors that multiply to 6 and add up to 5, which are going to be 2 and 3, both positive, plus 2 plus 3. And that's how we're going to factor all of these. If I do the bottom, similarly, I know that it begins with a positive 1x squared. So I know my first two places are going to be x. They need to multiply to 2 and add up to positive 3. So I know it's going to have to be the only factors for 2 are 1 and 2. 1 times 2 will give me 2. And added together, positive 1, positive 2 will give me positive 3. So I always want to make sure that when I'm multiplying them, it gives me what I'm supposed to get here, positive 2, including the sign. And then also when I'm adding them, don't forget that it needs to be a positive 3. So once we factored out this first fraction, I'm going to do the same to the second one. And again, starting with a positive x squared, I know my first two terms have to be x for the groups. And now multiplying to 5 and adding up to 6, 1 and 5, and both positive. Similarly down here, two groups, beginning with x's, and then multiplying to 8 and adding up to 6. So I think of factors of 8, 1 and 8, 2 and 4. It would have to be 2 and 4 so I can get positive 6, both positive. Multiply to positive 8 and add up to positive 6. So whenever I start off with a problem like this, I need to make sure it's multiplying. If it's not, if it's a division, I need to change it to a multiplication. But since we started out with a multiplication, all I have to do is factor everything, and now I check for any common groups. Now the common groups that can cancel out is anything within the same fraction, top to bottom. So anything in, like for instance here, the x plus 2 and the x plus 2, I have one in the numerator and one in the denominator. I can cancel those out. And then if I look at this fraction, there's nothing I can cancel out in the same fraction, top to bottom. So now I'm going to look diagonally. Is anything from the numerator of this fraction matching with anything in the denominator of my other fraction, and vice versa? And here I do have an x plus 1 at the numerator of my second fraction and the denominator of my first fraction. So if I look vertically and diagonally, I can cancel out. And I can only cancel out one group at a time. So even though I have another x plus 2 here, because it's just one at the top and one at the bottom that I cancel out, I can't cancel out every x plus 2. So it's just one at a time. And now after, once I've canceled out as much as I can, I rewrite whatever's left over. X plus 3 from the first fraction and x plus 5 from the second fraction were my leftover numerators. And from my denominators, I canceled out everything in the first fraction, but my second fraction still has x plus 2 and x plus 4. And that's my most simplified answer that I can get.